Hello, welcome to Regal Achievers Educational Ltd, presenting Real Tutor, trusted for brain-friendly and high-impact learning. We are still on paper 1, but the topic we are going to be looking at now today, course of study, is going to be chemical change and reactivities of metals. Now, what is chemical change? A chemical change is a process where a substance transforms into one or more new substances with different chemical properties through a chemical reaction. That's what chemical change is all about. Now, in this course of study of chemical change, we'll be talking about reactivities of metal, meaning talking about looking in detailed notes of what metal oxide, reactivity series, reactions with water and acid, and extraction of metals. Take note of this. These are the targets for this particular topic for your GCSE. So the first analysis is metal oxide. Now, what is metal oxide? Metal oxide is when a metal combines with oxygen. Yes, that is why in the very first point there you see metals plus oxygen forms metal oxide. And we should all know that metal oxide is a binary compound. The word binary compound simply means two elements only. Good. And also, you should know that the process in which metal combines with oxygen simply means metal has gained oxygen. That process is called oxidation. Now, the other aspect of it, which is reduction, which is the loss of oxygen, is important in metal extraction. So we should take note of this. Metal plus oxygen, metal oxide, metal gains oxygen, oxidation, the loss of oxygen, reduction, which is important in what? In the extraction of what? Metals. I will say that. Let's look at why metals are reactive. Now, number one reason, metals form positive ions. Now, to form positive ions simply means they tend to lose electron. Yeah, they lose electron to form positive ions. Now, two, reactivity depends on how easily they lose electrons. Yes, that's to say that and a metal who tends to lose one electron is more reactive than the ones that lost two, and the one that lost two is more reactive than the one that lost three. Which means metals that lost one electron tend to be more reactive, majorly. Okay, so having said that, we should take note that more reactive metals lose electron easily compared to those that are less reactive. Now, look at this table here. This is a table that shows the reactivity series of metal. As you can see, potassium there, sodium there, lithium, calcium, magnesium. Take note, carbon and hydrogen are non-metals. Now, in this reactivity series, you can see that potassium is placed upwards, which shows that potassium is more reactive than sodium, and sodium is more reactive than lithium, lithium more reactive than calcium, calcium more reactive than magnesium. And looking at the table, you can see that the reactivity decreases down the group, and this trend shows that copper is the least reactive and potassium is the most reactive. Now, I haven't talked about the reactivity series. Now let's talk about metals reacting with what? With water. Now, looking at this, potassium reacts violently with water because it's more reactive, unlike sodium, which reacts very quickly. Lithium also quick, and calcium slower. You can see that as we move down the group, the rate at which they react with water decreases. That is one thing you should know. So, which of them show more violent reaction is potassium. Reaction with dilute acid also. Calcium reacts very quickly with dilute acid, magnesium quick, zinc fairly slow, iron more slow, and copper very slow. You can see that it could react or maybe it could not just react, stuff like that. I haven't talked about that. Let's talk about one important thing in the reactive series, which is talked about what now? Displacement reaction in reactive series. In this type of reaction, we should take note that the more reactive metals displace less reactive metal. Example, let's assume magnesium reacts with copper 2 sulfate. When magnesium reacts with copper 2 sulfate, magnesium is way higher than copper in the reactivity series. If you look at the table earlier, this shows that magnesium will tend to displace copper from copper 2 sulfates, forming magnesium sulfates and depositing copper metal or displacing copper metal from it. So that's the displacement reaction. So we should take note of that. I won't talk about displacement reaction now. Let's go to extraction of metal. Under the extraction of metals, we should know that gold is found as a native metal, very unreactive, so it is found naturally. While most metals are found as a compound, meaning those are more reactive than gold, because a more reactive metal will tend to combine with other elements. Yes, here is a table of how metals are extracted from their ores. Example, more reactive metals such as potassium, sodium, calcium, magnesium, aluminum, they are extracted by electrolysis or through electrolysis. While metals such as zinc, iron, tin, lead are extracted by bonding with carbon, that is a reduction process. While some like copper, mercury extracted by bonding in air, as for silver and gold, like I said, there's no extraction needed because they are native metals. They are very, very unreactive. Now, that is all you need to know for this particular class. Now, let's answer some GCSE question. The first question on our list is this. It said the figure below shows parts of the reactivity series of metals. The non-metal carbon has been included, like I said earlier from our discussion in the class. You have potassium, lithium, carbon, zinc, tin, and gold. Because you can see the arrow pointing downwards, showing that decreasing reactivity. Now, that says something. Metal can be extracted from their compounds by electrolysis and also by reduction with carbon, which I also stated earlier. Now, electrolysis is more expensive than reduction with carbon. And they said predicts one metal that would be extracted by such method. Use the figure above. Extracted by electrolysis is your potassium, while extracted by carbon is your zinc. Now, I would say that we should take note of something. Lithium can also be extracted by electrolysis because it's both carbon and all that, and also more reactive than every other metals below it. And we should take note that gold cannot be extracted by reduction. It does not require any extraction process. Like I said earlier, it is what now? A native metal. Now that we've answered that question in particular, now we already understood what extraction of metal is and what the reactivity series is. Now let's go to the next question on our list. Now this question says, the question is about the energy change of reaction. Zinc reacts with copper sulfate solution. The word equation for the reaction is this. That said, zinc reacting with copper sulfates produces zinc sulfate and deposits copper. That said, what type of reaction is the reaction between zinc and copper sulfate solution? This is way too easy. I just stated earlier. This is displacement reaction. Yeah, that is displacement reaction. And thank you very much for joining us into this class. And God bless you. See you in my next class.